So let's get right into it. How did a 26-year-old patent clerk of all people basically rewrite the rule book for reality itself? We're talking about Albert Einstein, and back in 1905, he just completely turned our understanding of the universe on its head.
You know, for the longest time, we all thought we had the universe pretty much figured out. It was comfortable. Space was just this big, unchanging box, and time was like a river that flowed at the exact same speed for everyone. But then Einstein came along and just shattered that idea. He showed us a cosmos that's way stranger, way more flexible, where your reality, your actual experience of time, literally depends on how fast you're moving.
Right, so before Einstein, we had this idea of a clockwork universe. And, honestly, it made a lot of sense. The thinking was that there was one single master clock for the whole cosmos, ticking away at the same pace for everybody, everywhere. Simple as that.
And this is all just common sense, right? I mean, space is like a big empty room, time is this steady river, and a second for me is a second for you, even if you're flying in a jet. It all just works. A nice, tidy clockwork universe. But, and this is a big but, there was a tiny crack in this perfect picture, a problem that nobody could quite figure out.
And that problem? It was light. Scientists started looking at light really closely, and they found something weird. Something that just didn't play by the rules of that old clockwork model. And this one weird thing about light is what started Einstein on his entire journey.
Okay, so here's the rule, and it's an absolute game changer. The speed of light. It doesn't matter if you're racing towards a light beam in a rocket ship or running away from it, its speed is always the same. Always. It is the one and only cosmic speed limit. And that one single fact, it basically broke everything we thought we knew about physics.
So this is the exact puzzle that Einstein obsessed over. Think about it. If speed equals distance divided by time, and the speed of light cannot change, then something else in that equation has to. Something that we thought was completely solid and unchangeable has to be flexible. It has to bend. So what gives?
And this is where we get to the first huge, shocking consequence of all this. It's the core of what we call special relativity. Einstein just accepted the speed of light as a fact, and he followed the logic wherever it went. And where it went was completely mind-bending.
Time. Time itself is what has to give. That's the answer. If the speed of light is the one absolute thing, then time can't be. It has to be flexible. It means your time and my time are not the same if we're moving at different speeds. The universe is literally bending time all around us, and we don't even notice. This crazy effect has a name. It's called time dilation, and what it means is that the faster you move through space, the slower you move through time. And this isn't just a fun thought experiment, it's real. It's been measured. Astronauts on the International Space Station are moving super fast, so when they come back to Earth, they've actually aged just a tiny bit less than the rest of us. They're literally younger because of it.
You know, it was actually one of Einstein's old professors, Hermann Minkowski, who really grasped the full implication of this. He said this beautiful thing, that space and time by themselves are just shadows. He realized they're not separate concepts at all. They're woven together into one single fabric, a four-dimensional thing called spacetime. So moving through space isn't separate from moving through time. They are fundamentally linked.
But hold on, because Einstein wasn't finished, not by a long shot. About 10 years later, he decided to tackle another giant, gravity. He wanted to figure out what that force that keeps us all stuck to the planet really is.
And this later physicist John Archibald Wheeler summed up Einstein's new theory of gravity, what we call general relativity, absolutely perfectly with this quote. It's this incredible dance, a two-way street between all the stuff in the universe, like planets and stars, and that space-time fabric we were just talking about.
So forget everything you learned about gravity being some mysterious pulling force. That's not it at all. Imagine space-time as a giant stretched-out trampoline. Now you place a heavy bowling ball, that's the sun, in the middle. What happens? It creates a deep curve, right? Well, if you then roll a smaller marble, that's the Earth, nearby, it doesn't get pulled by the bowling ball. It just follows the curve that the bowling ball made. That path, that rolling along the curve, that's what we feel as gravity. It's not a force, it's just geometry.
Okay, so I know this all sounds like super abstract cosmic stuff. Bending time, curved space. What does that have to do with us? Well, turns out you probably have a device in your pocket right now that relies on this theory every single second.
Yeah, this isn't just some wacky theory for physicists to debate. It's real-world infrastructure. It's the invisible foundation that makes a huge part of our modern world possible, especially how we find our way around.
Think about your GPS. It works by talking to a bunch of satellites whipping around the Earth at high speed. Now, because of everything we just talked about, two things are happening. One, they're moving really fast, so their clocks tick a tiny bit slower. But two, they're farther away from Earth's gravity, which actually makes their clocks tick faster. When you combine both of Einstein's theories, the net effect is that the clocks on those satellites run just a little bit faster than ours do down here.
And that tiny difference in time matters a lot. If the GPS system didn't have Einstein's equations built right into it to constantly correct for that time drift, it would be totally useless. The little blue dot showing your location would be off by several kilometers within a single day. So next time you use your map app, you can thank Einstein.
So beyond the cool tech, there's a much deeper impact here. Relativity isn't just about physics, it's about philosophy. It forces us to ask, what even is reality?
So what does this all mean? It means there's no single master clock for the universe. There's no now that's the same for everyone. Every single one of us is carrying our own personal clock, ticking at its own rate. Reality isn't some fixed absolute thing out there. It's relational. It's a dynamic dance between you, me, and the flexible fabric of the universe itself.
I love this quote from Richard Feynman because it hits the nail on the head. The way the universe actually works is so much weirder, so much more creative than anything we could have just dreamed up.
Our brains evolved to throw rocks and find food, not to understand the bending of space-time. But Einstein, he gave us the tools to peek behind the curtain and see just how wild it all really is.
And it's just amazing to think that this whole revolution, this completely new vision of a universe where time can slow down and space can literally curve, it all came from one person asking a really simple question. What happens if the speed of light is the one thing that never ever changes? That one question changed everything.